All right, so yesterday we added, subtracted, and multiplied our functions. Today we're going to be dividing them. So it's the same process. We just have to divide. So this is the first thing that it's asking, is to find f divided by g. Second thing that this question is asking us for is the domain. And the third thing is to find when x is equal to 16. So there's 3 different parts to this question. So the first thing we want to do is find f divided by g. So question 1 is f divided by g of x. So we take our function f and divide it by g. So 6x divided by x to the 3/4 power. Now our x's have the same base, so what could I do to combine them together when dividing? Subtract the exponents. What's my exponent of the x on top? 1. So that 6 just stays out front, and I subtract the exponents. It'll be 1 minus 3/4. So this is 6x to the power of 1 minus 3/4. How do I subtract with fractions?
Multiply the 4 to 1
So I can change 1 to be 4/4. We need a common denominator, so that's why I changed it. And then we just subtract the numerators. So this would be 6x to what power? To the 1/4 power. So this would be our answer to question number 1. When we divide it, we get 6x to the 1/4 power. The next thing we want to do is plug in 16. So I'm going to skip to the third part of this question and find when x is equal to 16. So f of g of 16. So we plug in 16 into our x here. So I have 6 times 16 to the power of 1/4. How can I simplify this?
The 4th root of 16 times 6.
Perfect. I changed the 1/4 power to be the 4th root because 4 is my index. So this is 6 times the 4th root of 16. We can break down 16, or if we've done these enough, we know that the 4th root of 16 is what? 2. So this is 6 times 2. If we didn't know that right off the top of our head, break down 16. Circle your groups of 4. So 2 would come to the outside. So 6 times 2 is what? 12. So our answer to the third part of this question would be 12. So the last thing we're going to do is answer our second part of this question and find the domain. So our domain, we have to check the domain of f, the domain of g, but since we're dividing, we have one additional thing that we have to check. We have to check our denominator because we can't have 0 in the denominator. So the denominator cannot equal 0. So for the domain, there's 3 things we need to check. The first thing is the domain of f. Second thing is the domain of g. And third thing is the denominator. So let's check our domain of f, our function f here. So when we find the domain, we just need to check and see, do we have a square root or do we have a fraction here? So for 6x, is there a square root? Is there a fraction? No. So what's our domain? All real numbers. So the domain of f is all real numbers. If I put that on a number line, so I'm going to put all 3 of them on a number line to see where they overlap. It would be the whole number line, all real numbers. Does everybody understand how we found that domain? So we just need to check for our domains of the function if you have a square root or if you have a fraction here, if x is in a fraction. For 6x, we don't have either one of those, so it's going to be all real numbers. So if you don't have a square root and x is not in the denominator of a fraction, it's going to be all real numbers every other time. Now we need to check g. So we have to be careful when we have a fraction as an exponent. We want to write this as our radical. So what would my index be here? 4. So I have the 4th root of x to the 3rd power. What can I not have under the 4th root? Negatives. We can't have negative numbers. So for my domain of g, how would I write that? Well, can I plug in 0? Yeah, so it would be 0 to infinity, or you could say like from 0 to infinity. So we include 0 on our graph here, and it goes to the right. It can be any number bigger than 0. That's going to be the last thing that we check. The last thing we want to do is check our denominator. So we have to check the domain to make sure that our denominator is not 0. So what's our denominator, f or g? G. Here we have our denominator. The denominator cannot be 0. So we're technically just solving to see where this is equal to 0, and we're going to make sure we include that number in our domain. So x to the 3/4 power is equal to 0. What value of x would make this equal to 0? 0. So x cannot be 0. So we have to include that in our domain. So I technically have a hole here because x can't be 0. So we need to see where these 3 lines overlap. And we write that as our domain of the whole thing. So we have to include what overlaps between these 3 things. So what overlaps here between the light blue line, the green line, and the yellow one? What would my domain of the entire function be? So x is, it can be greater than 0, but can it be equal to 0? No, we said x can't be equal to 0 because we had to check our denominator. So we would just say x is greater than 0, or you could write it from 0 to infinity. But notice here how I have a parentheses because this means that 0 is not included. So we put a bracket when 0 is included, but here we said x cannot be 0. X is not equal to 0. So I would put a parentheses. You can write your domain as one of these 2 ways. Either way is fine. Whatever way you like better, you can stick to that way. So x is greater than 0, or you could say from 0 to infinity. So this next question is asking us for a lot of different things here. We have to find f times g of x. So this will be the first thing. I'm going to stick with the multiplication part first. So f times g, I've defined f times g of 32. So this will be the second thing I'm going to find. And then the third thing will be the domain of f times g. And then we'll worry about the dividing. So let's find the multiplication parts first. So for question 1, we're finding f times g of x. So we're going to multiply f and g together. So 3x times x to the 1/5 power. So my bases here are the same, so I can combine the x's together. When multiplying, how would I combine the x's together? Add the exponents. What's the exponent on the first x? 1. So the 3 just stays out front, and we add the 2 exponents. So it's x to the power of 1 plus 1/5. I can change the 1 to be 5/5. And then we just add our numerators together. So this becomes 3x to what power? the 6 over 5 power, to the 6/5 power. So when you're multiplying, you add the exponents. If we were dividing, we subtract the exponents. The second part of this question says we have to find f times g of 32. So what does that mean? What do I have to do here? Plug in 32 into the x. So I have 3 times 32 to the 6/5 power. How would I simplify this? I got to do it the exponent first. Remember PEMDAS. Got to do the exponent first. What do I do to that exponent? What's my index? The index is 5, so that goes out front of my radical. So it's 3 times the 5th root of 32 to the 6th power. Number on top stays on top. That's my exponent. What is the 5th root of 32? 2. Perfect. So this is 3 times 2 to the 6th power. What's 2 to the 6th power?
That would be 64.
64. And what is 3 times 64?
206.
192.
Oh,
So that's our answer to question number 2. Alright. Sticking with the multiplying part, we're going to find our domain for when we multiply. So the domain of f times g. So we got to check our domain for f and our domain for g and see where they overlap. So first I have 3x. What is my domain for 3x? Why is it all real numbers? Because there's no fraction and there's no square root there. So this would be all real numbers. Now I want to check my domain for x to the 1/5 power. We know that a fraction as an exponent is technically a radical, so let's change this to look like a radical and see what our domain would be. What's my index? 5. So this is the 5th root of x. Can I take the 5th? Can I have negative numbers under the 5th root of x? Yes. Why? Because it's odd. So what's my domain here? All real numbers. Awesome. What overlaps between these two domains? Everything. So what would my domain of the whole f times g be? All real numbers. So because they are both all real numbers, the domain of the whole thing is all real numbers. So again, the only time it's not going to be all real numbers is if you have a square root of x, because what can I not have under the square root?
A real number.
Negative numbers. And it's only when it's an even index. So if you had like the square root or the 4th root, these have to be positive numbers. Have to be positive values for x. And then the other time is if you had a fraction. If I had something like 1 over x, what can x not be? 0. X cannot be 0. So these are the only two cases where you have something other than all real numbers in your domain. If you had x, the square root of x, the 4th root of x, or x in the denominator of a fraction. Okay? Everything else is going to be all real numbers. If you had x to the 5th power, what would that be?
X to the 5th power.
What's your domain? All real numbers. Perfect.
It's not even.
It's not one of these two.
It has to be even, right? Even over x squared root.
Any exponent, like x to the 3rd power, or x squared, or x to the 10th power, these are all real numbers. Because they're not one of these two.
Wait, x to the 10th is even. Oh, yeah.
It's only an even index, not an exponent.
X is exactly.
Okay. So we found all the multiplying steps here. So now let's do the same thing but with the dividing ones. So I have to find f divided by g. So I'm going to call this, what did we leave off on? Question 3. So this will be question 4. We need to find f divided by g of 32. So this will be question 5. And then we have to find the domain of this, which will be question 6. So let's do the same thing now, but we are dividing. So question number 4 says we have to find f divided by g of x. So we take our function f, which is 3x, and divide it by g, which would be x to the 1/5 power. Can I simplify this? How? Since I have an x on the top and on the bottom, I can combine the exponents how? By subtracting. So this would be 1 minus 1/5. So this is 3x to the power of 1 minus 1/5. What do I need if I'm going to subtract exponents? Subtract fractions. I need to make the 1 what? 5/5. Because we need a common denominator. So this would be 3x to what power? It's the power of 4/5. Perfect, because we just subtract our numerators and keep the denominator the same. So that's our answer to the first part of the question. All right. For the 5th part of this question, we have to find f divided by g of 32. So what does that mean? What do I have to do here? Plug in 32 for x. So 3 times 32 to the 4/5 power. How would I solve this here? What's my index? 5. So the 5th root of 32 to the 4th power. Because the index is the denominator. The exponent is the numerator. What's the 5th root of 32? 2. So this is 3 times 2 to the 4th power. What do I have to do next here? What's 2 to the 4th power? 16. So this is 3 times 16. What's 3 times 16? 48. So that's our answer to the 5th part of this question. I promise on the quiz and on the test, these questions will be like spaced out. It'll just ask for one thing at a time. So my goal is not to confuse you with the question. I'll probably just ask for like you to add them. That'll be one question. Subtract. That'll be another. So it's not going to ask for 10 different things in one question. All right, last thing we want to do is find the domain. So this is question 6. We have to find the domain of f divided by g. So it's different when we are dividing because there's 3 things we have to check. We have to check the domain of f, we have to check the domain of g, and we have to check the denominator. Because what can the denominator not be? 0. Well, we already found the domain of f. What did we say that was? All real numbers. So all real numbers. What was the domain of g? All real numbers. And now we want to check the domain of the denominator. So going back to our fraction here, we know that our denominator cannot be 0. What value would I have to plug into x to make this 0? 0. So we know that x cannot be 0. So then we have 0 in our denominator. So for our domain, what would overlap here? All real numbers, and everything but 0. So everything but 0. So our domain for the whole thing, you can say all real numbers except 0. So you don't have to write it in interval notation or anything like that. I think the easiest way to do it would just be say all real numbers except 0.
Is that the same as like the parentheses 0 and then?
If you wrote it like the parentheses, because we're including negative numbers, it would be negative infinity to 0, and then from 0 to positive infinity. So this would be the same thing as writing all real numbers except 0, so I'd just do it this way. All right, so when you're finding the domain, when you're adding, so if I had f plus g or f minus g, so subtracting or multiplying f times g, the only two things that you have to check are the domain of f and the domain of g, and see where they overlap. But when you're dividing, if you have f divided by g, here you have to check for three things: the domain of f, the domain of g, and where the denominator is not 0. So we have to check all three of these things. So when you're adding, subtracting, or multiplying, your domain's always going to be the same thing. It's just the overlap between f and g. But for dividing, you have one additional step to do, which you have to check the domain of the denominator. You just have to include when the denominator is not 0. So let's look at example 5, because there's some like this in the homework. So for these types of questions, you can use your calculator. So in the homework, there's questions that say round your answer to 2 decimal places. For these questions, you can use the calculator. So it asks us to evaluate f plus g when x is equal to 2. So I'm going to find f plus g of 2. So we take our f and we take our g and add them together. So it'd be the square root. I'm going to leave it with x's for now, and then I'll plug in 2's. We're just adding our two functions together. So square root of x plus the square root of 9 minus x squared. So this would be the square root of 2 plus the square root of 9 minus 2 squared. So the square root of 2 can't be simplified, so this is why you need your calculator. So just plug it in the calculator. For the second one, we would get 9 minus 4, which would be 5. So you have the square root of 2 plus the square root of 5. For this, just put them both in the calculator, add it together. So just be careful when you put it in the calculator. Do them separately and then just add it together. You should get 3.65 when you put it in the calculator. So for all of these questions, you're just doing the same thing. For the next one, plug in 2, but you're just subtracting them. For multiplying, find your two answers, multiply them together. So you could either plug in 2 into this and plug in 2 into this and do it separate, like do it at the end, or you could just do it all together. So for these, you're just plugging it into the calculator. It depends on your calculator. Like some calculators, like the one that I use, if you put the square root of 2, it like leaves it open, so then it thinks that it's like the square root of 2 plus the square root of 5, like that. So you would have to close your parentheses. So you can practice putting these in the calculator. I'll post the answers to tonight's homework so you can kind of check and make sure you're putting it in the calculator right.